Hello and welcome to this video brought to you by Smart Exam Resources. In today's video, I shall be explaining to you the topic heat energy. So before I begin, I would like to make a small announcement with regards to the free mock examinations that we shall be conducting for the students who are going to appear for the Cambridge Lower Secondary Checkpoint Science exams for stage 9. So the only thing that you need to do is you need to register your interest by sending an email. The email address shall be um, conveyed to you at the end of the video. So you need to email to that particular address stating your interest and your country because we need to know which time zone you are in. So accordingly, we'll have to ask you to finish writing the exams. Now, the exams can happen online, they can be interactive, or you can download them, the papers at home, and you can solve them physically. So you have options. Basically, it depends on the nature of the test that if we would decide to conduct. But one more thing to remember is that these tests are 100% free. We are not charging anything um, for these examinations. So the only thing you need to do is to register your interest by emailing us. So this is a test which is available for paid as well as unpaid members. So whether you're purchasing the membership, you have already purchased the membership, that's a different thing. But the tests are going to be available for all students. And it is better that you subscribe if you have not subscribed to the channel so that you get to know exactly when these examinations will be conducted because you will have to finish writing the examination and then soon after that we shall be discussing the complete exam paper online for all the students, and it is better that you stay online at the same time so that will help you to understand your mistakes, if at all. And if you have some kind of queries, you are um, allowed to email us. But see that you mail us early so that we are able to reply to you well within time. Okay, so now let us begin with our notes. These notes are already present in the members area for students who have taken the paid membership. If you are not a paid member, then you can always come and watch this video online. So the first topic that we shall learn today is energy. And first thing you need to understand that there are codes written throughout the notes 9PF01 etc. Those are the codes that are present in the Cambridge syllabus, and these are for the teacher's reference. So it's okay if you do not go through that, but if you read through them, you'll understand what the Cambridge is expecting you to know in terms of concepts. Because examinations are based on the concepts and not what the authors are giving you. Sometimes they give you extra, or school sometimes teach you extra concepts. So that's okay, but what you'll be assessed on these are the objectives that you'll be assessed on. So fine, let us begin. The first thing is that heat is a form of energy. So since heat is a form of energy, it flows from hot objects to cold objects. So for example, when you touch a hot cup of tea, heat flows from the cup to your hand. That's why it feels hot. Another example you can think of is you take ice cube on your palm and you see it is melting. So why is the ice cube melting? The ice cube is melting because the ice cube is absorbing heat from your palm because your palm is at a higher temperature as compared to the ice cube. So because the heat is flowing from your palm to the ice cube is melting. So this is an example of the flow of heat energy from hotter objects to the colder objects. Next we talk about is temperature. So children generally feel that heat and temperature are the same things, but no, heat is a form of energy, and temperature is a measure of the average kinetic energy of the molecules. So, for example, imagine that there are 10 molecules. So, whatever energies those 10 molecules are possessing, The average of those kinetic energies is the temperature. So, temperature is the measure of the average kinetic energy of the molecules. In defining the word temperature, it is very important for you to mention the word average kinetic energy. If you only mention temperature is the measure of kinetic energy of the molecules, you get it wrong. Next is temperature is measured with the help of a thermometer. So since temperature is a measurable quantity, you obviously need an instrument to measure the temperature, and this temperature is measured with the help of a thermometer. So the instrument is a thermometer. I'm sure you all must have used a thermometer or seen it at home in laboratories, etc. Next, we talk about the conservation of energy. I shall read out what is written here. Energy is always conserved. It can neither be created nor destroyed. It can only be changed from one form to another. The total amount of energy in the universe always stays constant. So, this is a very important concept, and you will find that this concept will get repeated even when you go to IGCSE, when you go to your A levels, because this is a concept which is a key concept in physics. So, you need to understand every word of it and understand that you need to write the keywords again because examinations are all about the scientific terminology. So, if you do not use the right vocabulary, you tend to lose marks. So the first thing is energy is always conserved, means it is preserved, but we always say conserved. So energy is always conserved. It can neither be created nor destroyed. You can't create energy, you can't destroy energy. It is always conserved. Okay? It is always conserved. It can neither be created nor destroyed. So then what happens or what can be done? It can only be changed from one form to another. So maximum you can change the form of energy. Maybe the kinetic energy can change into sound energy, kinetic energy can change into wind energy, whatever. But you can only change forms. You cannot create it, neither can you destroy energy. And the total amount of energy in the universe always remains constant. So, to give you a simple example, when you switch on the fan, what is happening? The fan blades start to rotate, right? So, what is happening? The blades are moving in circles. Okay. So, you have supplied electrical energy and the blades are moving. And the energy that is due to the motion is called as kinetic energy. So, you have changed the form of energy from electrical energy to kinetic energy. So, but on the whole, only the form of energy is changed. You are not creating energy, you are not destroying energy. And the total amount of energy will always remain the same. Okay, fine. So now here on the screen, there's an example which is given for an endothermic reaction. Now remember, an endothermic reaction is a reaction in which heat energy is absorbed. Okay, and when this heat energy is absorbed, the energy is stored in the bonds of the products because reactants are absorbing energy. The energy is getting stored in the bonds and it's getting changed in stored in the bonds of the products because reactants change into products. That is when we say that the reaction has taken place or there's a chemical reaction. We come to know because from the reactants we are getting products. So in any reaction when heat needs to be supplied, that energy that is supplied gets stored in the bonds of the products. Okay, so that means energy is getting absorbed. You're adding energy. So in an endothermic reaction, the products will always have stored energy, and this stored energy will be more as compared to the energy that is present in the reactants. But on the whole, the total amount of energy is always going to stay constant. Okay. Now, second example is of a cyclist. Now, if you look at the cyclist at position A, and position B, you will find that the cyclist A is on a ground level. So, and she is pedaling. So, the kinetic energy, the energy that a object possesses, the energy that an object possesses due to its motion is said to be kinetic energy. So, this cyclist here is possessing kinetic energy as she is uh, moving up the hill, she's also pedaling. So therefore, she's going a little higher and higher from the ground. So she's gaining potential energy also, because potential energy is an energy of an object which is possessed due to a position above the earth. So the cyclist at A, as she's going up the hill, she will have kinetic energy as well as potential energy. But when she reaches on the top and suppose she stops cycling there at position B, so she's at a ground at a higher level from the ground. So therefore she'll be having potential energy. But since if she's not pedaling, suppose she's not pedaling, so she'll only have potential energy. So what is happening? Initially she had kinetic energy and potential energy, but when she reached the top, her only energy we can say is potential energy. If she's pedaling again, she'll have potential and kinetic energy. So if she is pedaling and on the level ground only, she'll have kinetic energy. As she goes higher, she'll have both the energies. So energy conversion keeps taking place. But on the whole, what is happening? The total amount of energy is remaining the same. So kinetic energy is getting changed into potential energy, and potential energy into kinetic energy. Then again, if the cycle is making noise, there's sound energy, there's friction. So some parts of the tire are getting heated, so there's heat energy. So different forms of energy are getting generated in the whole process, but the total amount of energy is remaining constant. So there's only energy conversion that is taking place. Now look at this clock on the screen. This is a third example. So if there is no battery, you do not see the clock hands moving. The moment you put a battery, the clock hands start moving. Of course, if the clock is working. So, what is happening over here? We all know that battery has chemical energy. That chemical energy of the battery is getting changed into the kinetic energy of the clock's hands. So there is an energy conversion that is taking place. And we know after some time we need to change the battery. We need to replace the battery because the energy is converted. Okay. And when the clock is moving, the energy gets changed into heat energy because there is friction between the moving parts. So there's some kind of noise that is coming. The the clock is ticking. So all those things happen. So whatever is there, heat energy, sound energy, whatever form of energy is there, that is because there's an energy conversion taking place from chemical energy. So chemical energy changes to kinetic energy, chemical energy changes to thermal energy, it changes to sound energy. So once again, there are different forms of energy. So nothing is being created, nothing is getting destroyed. Energy is only changing forms. So, on the whole, the total amount of energy in the universe is going to stay constant. This is about the conservation of energy and the forms of energy and the interconversion in the different forms. So, you need to remember all these concepts. These are the key concepts. Then you talk about the heat dissipation. Now, only thing that is important here is you need to understand what the term means. So it means that thermal energy will always transfer from hotter regions or hotter objects to colder ones. And this is known as heat dissipation. This is what you need to know for the time being. Okay, now the next thing that we will learn is about the thermal energy transfers. So whenever energy transfers take place, there are different ways in which these transfers take place. The ways are conduction, convection, and radiation. So we shall study every method of heat transfer in detail now. So, beginning with conduction, first I shall read out, then I shall explain to you. So, in conduction, heat energy is transferred from one particle of a material to the next particle. Next thing about conduction is conduction can happen easily in solids, but less easily in liquids and hardly, if at all, in gases. And the last thing is conduction does not occur in vacuum. There are no particles in vacuum to pass on the heat energy. So conduction is all about particles. So let me give you an example. Suppose this is These are the solid particles. Suppose these are the solid particles. So, what is the first line telling you? In conduction, heat energy is transferred from one particle of a material to the next. So, this particle is transferring the energy to this particle. Then, this particle is transferring the energy to its neighboring particle. So, what is happening? Energy is getting transferred from one particle to another particle. Now, they are telling you that conduction can happen easily in solids but less easily in liquids and hardly if at all in gases. Now you know the particles in a solid are close together and the particles in a liquid are a little further apart. So suppose this is a liquid, the particles will be a little further apart. And if this is a gas, one particle will be here, the other might be somewhere here. So since conduction involves the transfer of energy from one particle to the next, it can happen obviously easily in solids. This is my solid, but in liquids, what's happening? The particles are further apart, so conduction might happen, but very slowly because the particles are spread out further. Now, in gases, since the particles are so further apart, conduction, if at all it will take place very slowly. It might take hardly in gases because the particles are dispersed or they are spread out. So, this is what they mean by conduction. So, for conduction, remember that heat energy is passed from one particle to another particle. Okay. So, if the particles are close by, conduction can happen better. If the particles are spread out, it happens to a lesser extent. And like if the particles are extremely spread out, conduction might not happen. And if at all it happens, it will happen very slowly. Okay. And as mentioned, vacuum does not have any particles. So conduction does not happen in vacuum as there are no particles in vacuum. Okay. Since there are no particles, heat energy cannot be passed on. So this is about the conduction. Now, in order to explain in detail the actual process of conduction, I shall take an example. I shall draw a diagram here. Now, suppose this is a metal bar or a metal strip, and these circles that I'm drawing inside are the metal atoms. Okay. And remember, this is a concept that you'll be um, learning even in the IGCSE. So, whatever you're learning right now in the stage 9 of checkpoint, that will be very useful for you when you're um, appearing for your IGCSE board exams also. So in the IGCSE or even in your checkpoints, they can ask you to draw uh, the internal structure of a metal. So this is what is happening. So, okay. So as you can see on the screen, this is the metal strip and these circles represent metal atoms. So suppose this is copper a strip of copper metal and these circles are representing the copper atoms. So what is happening is that we always say that metals conduct heat, metals conduct electricity. But since this is a lesson based on the concept of heat, I shall talk about only heat now. So suppose I say that this copper strip conducts heat energy. So actually what is happening inside? Heat energy is being transferred inside, okay, because of a lot of free electrons. So if I'm speaking about atoms, I said that these are all atoms. So where did the electrons come now? So always remember that if this is an atom and if this atom loses electrons, okay, so then it changes into something which is called as an ion. So whenever an atom is losing electrons, it changes into a positive ion, okay? So in any metal strip, okay, you will find that there are a large number of free or mobile electrons because these electrons have broken free from their atoms. So these electrons, they jump away from the atoms and they change these atoms into positive ions. So actually inside the metal strips, these are the positive ions. All of these are the positive ions, okay? So all of these are the positive ions Okay, so I finished drawing all the positive ions by putting the plus signs. So now, since these are the ions, what is moving freely inside are the electrons. I will show them by dots. Okay, I can use another color for them. Maybe I can use a purple color. Okay, so all over here, these are the electrons. So in between, these are the electrons, okay? These are all the electrons here in between empty spaces. So what is happening now? Electrons are mobile in the sense they are able to move freely. So they are able to conduct the heat energy. So how are they able to conduct the heat energy? Now suppose that at this end, heat energy is supplied. So there is a flame and heat is being supplied here. So what is going to happen? This part is going to become hotter. Okay. So when this becomes hot, the average kinetic energy of the electrons will increase. So the electrons will start moving faster because they are free, they are able to move throughout the metal strip. So the electrons will start moving. Suppose I draw waves to show the electron moving. So the electrons will start moving, and while moving, suppose there's an electron here, they'll collide with the electron, they'll transfer some of the heat energy, some of the kinetic energy, and then they'll again move further, they collide with another electron, again transfer some of the heat energy, kinetic energy. So they keep transferring the energy while they are moving. So one electron, while it is moving from the hotter end to the cooler end, it is going to collide with other electrons and it is going to transfer its energy, some of its energy to them. So all other electrons are doing the same thing. They are moving from the hotter region, they are colliding with other electrons, they are giving away some of their energy, and when they are reaching this end, by the time they reach this end, heat energy also gets transferred here. Therefore, after some time, if you touch this end, you feel this end is also becoming hot. Okay, so there is a conduction of heat energy that has taken place. And who's done the conduction? The free electrons or the mobile electrons. Now, another thing you need to remember is they are also colliding with the metal ions, that is the positive ions. So when the free electrons are colliding with the metal ions, they're also giving away some of the heat energy to these metal ions, right? The third thing you need to remember is that these metal ions are also vibrating in their positions. Okay? Because their kinetic energy is increasing, they are also vibrating in their positions. So, on the whole, what is happening? Heat energy is getting transferred. So, heat energy is getting transferred either due to the mobile electrons that are colliding with the other electrons and transferring energy, or they are colliding with the they are colliding with the positive ions and transferring energy, or the heat energy is also passed due to the vibrations of the positive ions. So these are all the ways in which heat energy is transferred from the hotter part to the colder part. That is how the conduction process takes place. And it is very important for you to know all of this because they might ask you as a part of theory question somewhere, or this can come as fill in the blanks or whatever. But the concept is very important. So please do not overlook revising this. So I shall read this process of thermal energy transfer through conduction for you. Most metal, most metals contain a lot of free electrons called as mobile or conduction electrons. These are the electrons that have broken free from their atoms and thus changed them into positively charged ions. These electrons keep moving throughout the metal and are bonded by electrostatic force of attraction to the positive ions. Now, I'm sorry I missed out one point over here. So, the electrons keep moving throughout the metal, but it doesn't mean that now there is nothing that is going to attract them or hold them, or there is no control over them. No. So, there is a force of attraction that is existing between the positive ions and the mobile electrons, and that force of attraction is called as electrostatic force of attraction. So this is again a very key thing you need to remember, that electrostatic attraction exists between the positive ions and the electrons. Okay. When a metal is heated at one end, the free electrons at the hot end gain kinetic energy and move faster. These electrons diffuse, move faster, and in the process collide with other free electrons and metal ions in the colder parts of the metal. Thus, the kinetic energy is transferred by the electrons to other electrons and ions. So, like I told you, ions are colliding with the electrons are colliding with other electrons. They are also colliding with the positive ions. Okay. Thus, the kinetic energy is transferred by the electrons to other electrons and ions. In addition, the ions vibrate due to the increase in their kinetic energy. Thus, heat energy gets transferred from the hot end to the cold end by electrons as well as the metal ions. A very, very important concept. Okay, fine. I hope you understood. Now, let's move ahead. Okay, now here is an experiment which is based on the conduction again. So it says identifying the best thermal conductors. So first of all, I hope I'm able to make you understand the concept of conduction well, that when heat energy is conducted or transferred from one particle to the next particle, the process is called as conduction. So here, as you can see, uh, okay, I'll read it out to you rather. So in the adjoining figure, equal heat is supplied to the different metallic rods. The rod has the minimum number of wax rings left at the end of a particular after a particular time interval is the best conductor of heat. Okay, so what is happening is, since it is a science experiment, you need to do a fair test. So what is happening is equal amount of heat is supplied to different rods. Okay, so some rods might be made of copper, aluminum, zinc, or whatever, iron, etc. So we need to test which metal is the best conductor. Okay, now to make a fair test, like I told you, equal amount of heat is supplied. Four rods are taken, as I can see, and probably they have the same thickness, length, etc. Because again, that is important to keep in mind to make the test fair. And some little wax is fixed at the ends of the four metal rods. So when heat energy is supplied, obviously conduction will take place. Heat will travel from the center where the heat is being supplied. It will move towards the edges. Now, wherever there is the least amount of wax remaining, because heat is going to melt the wax, the moment the edges are going to become hotter, the wax is going to melt. So, as I can see, the copper rod has the least amount of wax remaining after the same amount of time, equal interval of time. This means that copper is the best conductor. And iron, I can see a lot of wax is still there. That means iron is a bad conductor. Okay, compared to copper. It conducts, but it is going to conduct less. Okay. So therefore, some utensils have copper bottoms so that cooking time is reduced. So these are all applications. They can ask you in the examination. They can show a utensil having a copper base, and they can ask you, why is this particular utensil having a copper base? So the answer is to save the heat energy, because copper conducts better than whatever the other metal is, if it is given iron, etc. Whatever. Okay. So conduction in non-metals is the next subtopic. Now I shall read this out for you and then I shall explain this to you. In a non-metal, there are no free electrons. Hence, when it is heated, heat only gets transferred via the atomic vibrations as the atoms are closely packed. This method of heat transfer is less effective as compared to conduction in metals. Hence, non-metals are bad conductors as compared to metals. So, what they're trying to tell you is, if you take any non-metal, suppose if you take wood is not a metal. So if you try to heat the wood, definitely wood will get a little warmer, but it will not get very hot, similar to any metal rod if you take and you supply the same amount of heat. The reason is because there are no free electrons in non-metals, and therefore heat is only transferred via the atomic vibration. So whenever the atoms are vibrating inside the non-metal, the heat is getting passed. Okay. to the neighboring atoms. Now, note a very important thing what I'm saying. For the metals, I am using the vibrations of ions. And here I'm talking about non-metals as the vibration of atoms because there are no free electrons. Obviously, there are all atoms inside the non-metals. Okay. So the atomic vibrations are the only reason why heat is getting transferred, and therefore non-metals are said to be bad conductors. Okay. Now, these are again another experiment. Two is again an example, which is based on conduction. Again, maybe two spoons are kept the same distance and the same height and in the same part of the flame, and you can see the wax is dripping from one of the spoons, and it is not dripping from the other. So possibly the second one is a non-conductor. It looks like it's made of wood, and the uh, spoon from where the wax appears to drip is made up of a metal, so therefore it is a good conductor. So these kind of examples you need to keep in mind. Read as many as possible examples from the net so that you are better prepared for your examinations, because application skills you can only pick up by referring to a large number of resources. There is no one resource that is sufficient for your preparation at any level. Okay, so now I shall read quickly the facts about conduction. Conduction is faster in metals. This is because metals have a large number of free electrons, also called as mobile electrons. When a metal is heated, the electrons in that part move even more faster and collide with the neighboring electrons and the vibrating atoms and pass on the heat energy. At the same time, vibrating atoms also pass on the heat energy. The conduction happens further in metals. Okay. Okay. So, so technically, I would like to make a small correction here. Since it is specifically talking about conduction in metals, you need to talk about vibration of the ions, okay? Because you know that the atoms have left the electrons, so the ions are going to vibrate in their places. And for non-metals, obviously, you can use the word atomic vibrations. So here it is written when a metal is heated, the electrons in that part move even faster and collide with the neighboring electrons and the vibrating atoms, no, and the vibrating ions and pass on the heat energy. At the same time, vibrating ions also pass on the heat energy. So I shall make the correction in the notes and re-upload them. So apologies for that error, but it's very important for me to correct it. So fine. So this is about basically whatever facts of about conduction are written. That's a summary of the entire process of conduction. Okay. Now looking at the conductors and insulators. So what are conductors? Materials that allow the heat energy to pass through them easily are called as conductors. Example, aluminium, copper, steel, iron, graphite. Note that graphite is a non-metal, but yet it is a good conductor of heat and electricity. Now, insulators, material that do not allow heat energy to pass through them easily, are called as insulators. Examples include plastic, rubber, polystyrene, foam, wood, glass, vacuum. All of these examples are extremely important. Okay, so try to remember this, and whenever I'm explaining to you, it is better that you take down the notes. When you make your own notes, make flow charts, things become easier. You don't have to then sit and reread again. You can make your small notes right now so that you can refer to them when you're revising even before your actual school exams or board exams. Okay. Now over here, applications of thermal conductors and insulators. So, like I told you, you need to cook the food really fast. So one would like to have a copper bottom if possible. Okay. And you need to have wooden handles for utensils so that you do not feel the heat while picking them up. Okay. Sometimes there are plastic handles, wooden handles, etc. So whatever it is. So I don't think that you need to there is any need for me to read all of this for you. Um, it is very clearly visible over here that the pan inside material is actually a good conductor. The handle of the cooker is a insulator. The pan handle is a insulator. Okay. So you can read through. You can pause the video and read through if you want. But I'm skipping it for now. Now the last method of transfer of heat energy is radiation. Let me read and then explain. Thermal energy travels through air or vacuum through radiation. Thermal energy is the transfer of heat by the means of the electromagnetic radiation generated by the thermal motion of particles in matter. So, what this simply means is that in radiation, thermal energy can travel through air or vacuum. It does not necessarily require a medium to travel. And this transfer of thermal radiation via the process of radiation happens by means of electromagnetic radiation. So, whenever the heat energy is transferred in this way, it is happening by means of electromagnetic radiation. And who is generating this electromagnetic radiation? The thermal motion of the particles in matter. One example we can take of cooking food. When you're cooking food, um, or when someone is cooking food, and if you uh, happen to enter the kitchen, you feel that the kitchen is a bit warmer, or sometimes it becomes hotter also. The reason if there is too much of food being cooked and for a long time, the room tends to get warmer. That is because of this kind of radiation. Okay, so there's thermal radiation happening, and because of the thermal radiation, heat is getting spread out. So you're not actually touching the utensil in which the food is getting cooked. You're not touching that utensil, but yet you feel the heat. This is because of heat transfer through thermal radiation. And thermal radiation is the reason why the sun's warmth is reaching the earth. Now, another example is being shown here where the hot soup is radiating the heat outwards. Okay, again, once again, heating the surroundings. Now, the next example is of a woman who's actually feeling hot because of the sun. She's not touching the sun, but yet she can feel the heat of the sun. And there's a person who's actually sitting besides a fire, and he's again maybe he's feeling cold, so he's trying to get the warmth from the fire. Okay, so this is all about the applications of thermal radiations, uh, the radiation process, whether it needs a medium or not. So no, it does not necessarily need a medium, but it can travel through air or vacuum. So then we talk about the process of evaporation. So technically, what is evaporation? I shall explain you this process. I shall read this first to you and then explain in detail. So the particles in a liquid have different amount of energy. So when you talk about, okay, I'll draw at the same time to make it easier for you. So suppose this rectangle represents some kind of liquid. Okay, it's a container in which there is liquid. Now, imagine that there are particles inside this, okay? So these are liquid particles. Okay. Now, what is it saying? The first one, the particles in a liquid have different amount of energy. Okay, so all particles don't have the same amount of energy, they have different amount of energy. Next, they are telling you the high energetic particles are the ones that can move faster in liquids. Obviously, when the particles have more kinetic energy, they are going to be able to move faster throughout the liquid. Now, next thing they're telling you, these high energetic particles, upon reaching the surface of the liquid, may be able to break their bonds with their neighboring molecules and escape. When this happens, we say that evaporation has taken place. So first of all these particles in a liquid might not have the same amount of energy. And suppose, and note that this is evaporation, this is not boiling. So you don't have to have a source, or you don't have to have this water, this liquid to be kept over a flame. There's no need. Even suppose there's a sun overhead, okay? Suppose, and the heat of the sun is able to provide the warmth, okay? It is also able to increase the kinetic energy. So what is happening over here? All different particles in the liquid might have different amount of energy. So suppose there are some molecules that have got more kinetic energy. So those are the ones that are able to reach the surface of the liquid here. And when they reach the surface of the liquid, they're able to break the bonds that they have with the neighboring particles in the liquid. Okay, remember there is some kind of attraction existing between the liquid particles. Okay, so when the high energetic particles are able to reach the surface of the liquid, they might be able to break the bonds that are holding them to the neighboring particles, and they might be able to escape out of the liquid. And when they are able to escape out of the liquid, we say that the liquid has evaporated. So actually what is happening when we say evaporation occurs, that means some of the liquid is changing into vapor. Okay, so which particles are able to break their force of attraction or break their bonds from the neighboring particles? Only the particles that are having a greater amount of kinetic energy. So those are the ones that are able to escape. So during evaporations, the particles with the highest kinetic energy are involved. So what happens to the other particles? These are the particles. Okay, I'll just put a line here. So suppose these are particles have not evaporated. Why didn't they not evaporate? They did not evaporate because they had less amount of kinetic energy. And you know that temperature is the measure of average kinetic energy. So if the particles with the low kinetic energy remain, okay, in the liquid and do not evaporate, that means the kinetic energy of the particles of the liquid decreases, because the ones with the most kinetic energy are able to break bonds and escape. So the particles that remain behind have low kinetic energy, and therefore the temperature of the liquid that is remaining in the container decreases. This means evaporation causes cooling. So technically, what is happening here? All particles don't have the same amount of energy. The ones with the highest kinetic energy are able to break their bonds with the neighboring molecules and escape. When they are able to break their bonds and escape, we say that evaporation has taken place. So the particles that are left behind have less amount of kinetic energy, and therefore we say that evaporation causes cooling as the temperature of the remaining water decreases. So uses of evaporation. Evaporation is necessary to regulate a body temperature to 37 degrees Celsius. Okay, so whenever we are walking in the sun, it's very hot and we start sweating. So what is happening? Because of the sweat, we have the water coming from from over the skin, and then we feel that whenever we sweat, our skin feels cold. This is because the water evaporates and it causes cooling. Okay, so evaporation causes cooling, and sweat is necessary for us to maintain our body temperature. Okay, then again, it is said that when we sweat, when sweat evaporates, it cools the skin. That I just explained that to you. Then another thing they are mentioning is that simply splashing water on your face creates a cooling effect on hot summer days. So we often do that. We splash water on the face and we feel cool, because again that water from the face will, if you leave it as it is going to evaporate after some time, and when the water evaporates, it's going to take away the heat from our skin. So that is how evaporation causes cooling. There are a number of examples that will help you to understand that evaporation causes cooling. Okay. And process of evaporation I've already explained to you. Below what you can see is just a summary of what I've explained until now. So, well, this is all in today's video on the topic of heat and energy. And once again, do not forget to subscribe to our channel. The only benefit you'll be getting from subscribing if you are a Cambridge Lower Secondary Checkpoint student is that you'll be able to appear for your mocks because dates will be announced in the video. And like I told you, you'll have to email um, at an address so that you can register yourself for the mock examinations. So the address will be support@smartexamresources.com. So I hope you've made a note of it. And well, that's all in today's video. Thanks for watching. Do not forget to like, share, subscribe. Okay? And subscribing will help you to get regular updates on our upcoming videos. So thanks for watching. Good day and God bless.